Thank you very much, sir. Good afternoon, ladies and gentlemen. It's a great honor for me to present our research on infrared radar, specially designed for the training purposes for the beginners. The research team as follows: Major KP Dhammika, Lieutenant Commander DWS Lakmina, Officer Cadet Ranasinghe, Officer Cadet Pereira, and myself, Officer Cadet Chandra. The flow of my presentation is as follows: the introduction, aim, IR radar, hardware, processing software, limitations, and finally the conclusion. Introduction. Radar is a method of using radio waves to determine the location of objects in space in relation to a known point. Radar transmits electromagnetic signals and receives echoes from the target objects and extract the location and other information from the echo signal. So in this research, what we have done was we have designed a close proximity infrared radar system that is used to detect any object to the device by scanning from 0 degrees to 180 degrees. It is a very low cost radar system comparing with others. This radar is basically very handy as a training module for the beginners. Unlike other radars, the distance to the object is directly on the radar screen. Aim. We present an infrared radar system which we have developed specially for the teaching purposes for the beginners. Hardware. These are the hardwares that we have used for our IR radar. Sharp GP2i0A02 series infrared distance sensor we have used as the infrared sensor, and the Arduino board. This is a microcontroller board that we have used for the data processing, and servo motors. Once the supply is given to the system, the Arduino will power up the servo motor, and then simultaneously the IR sensor also transmits and receives the signals. The IR waves are used as the source for our radar. The analog voltage output of the received IR waves is then processed to measure the distance. So this processing part is done by the Arduino board. The analog output of the sensor used as the analog input to the Arduino board, and it will be converted to a digital value by the analog to digital converter inside the Arduino board. Through the serial port of the Arduino board, we are taking the distance and the angle of the detected object at a 9600 baud rate. The angle values are obtained by the PWM output of the Arduino board. The radar interface is made by Java-based processing software, and finally the radar screen displays the distance and the angle to the object by a polar diagram. So this is the IR distance sensor that we have used, and in this sensor, both the transmitter and the receiver in the same module. This sharp IR rangefinder works by the process of triangulation. It calculates the distance by the process of triangulation. A pulse of light is emitted and then reflected back. When the light returns, it comes back to an angle that is dependent on the distance of the reflecting object. So the triangulation works by detecting this reflected beam angle. By knowing the angle, then we can determine the distance. So reflection occurs once the IR waves hits the surface of the object. So part of the reflected light will be then sent back to the receiver, and which another lens will combine these lights and determine the point of impact. So this is the calibration curve which was obtained by getting the voltage values for a stationary object for different distances. By varying the distances, we took different voltage values. So here we considered the white paper and the gray paper reflections only due to the time limitations, plotting by considering only those two reflections. Once the computer receives the commands from the Arduino, computer gives us the angle and the distance values on the computer screen. So this is the algorithm that we have used from the left side. We have write down the algorithm to get the values, the angle value and the distance value. from the right side you can see then x and v values corresponding to the certain angle value. There is a separate distance values we are taking from the serial port of the computer. The processing software. Processing is a tool that let us to program and code graphics and animation. So the speciality in this software is that it works hand in hand with the Arduino. We can directly call the, once we write down the algorithm, we can directly call it from the Arduino to send that data to this software. So the processing lets the data taken from the Arduino and whatever is plugged into it and then visualize it on the screen. So once we take the x and values, x and v values, x is the left right position, that is the angle, and the v is the distance. So we take the x and v values to the computer at a rate of 9600 baud rate. So once the computer took the details, then the processing software is, what is it's doing is that we have written down the code in this processing software. So it takes the details and it plot the map. So it's a polar diagram that we have used. So after that polar diagram, it will be displayed on the screen. This is the radar screen that we have plotted by using the processing software, which visualizes the sense objects. So in this radar screen, you can identify the degree, the angle and the distance, and also you can identify the object. So if the object is being moved, that is also can be identified. That will be shown from the radar screen. I will show you just a small video clip how it's working. So if we move the objects, then it will give it will indicate in this computer screen. So that can be used for many applications. This can be a useful training module for beginners. Because as we all know that we have to spend a lot of money for the radar system. So if we want to train the beginners, I think this is the best tool that we can use, because it is cost very little amount of money. So and when we are considering the radar systems, we know that we are using microwaves, so there may be health hazards, but in this radar system we don't have any health hazards. And also for the military applications, we can use as the mobile robots to avoid the obstacles. So this radar can be developed to use in ground surveillance robots and also in the armored robots. The application in this radar is that we are considering only the obstacle avoidance part only. So we can use for this kind of radar for mobile robots and also for protection of valuable items. So just consider in a museum or an exhibition, in showrooms, we are having valuable items. So if we want to protect something valuable, we can use this radar system. As I told you, we can identify whether when there was a motion, we can identify. So that can be coupled to an alarm system. Then we can identify that if the item has been stolen, then we can identify that the item has been stolen. So we can take necessary precaution actions. And can be used for home security purposes also. Limitations. The limitations which we have faced was the radar range. Actually, this sensor is having a very limited radar range. So our main purpose was to develop a training module for the beginners. So by considering that, we didn't care about the radar range much. But if we want to develop it, we need to consider about the radar range also, because it is about 20 centimeters to 150 centimeters range we are having in this sensor. And also the limited scanning speed, because it will take 20 milliseconds to rotate. That means from 1 degree per 20 milliseconds. So that is also an limitation that we had. We have to, if we increase the scanning speed, then the values we are getting might be wrong. And the radar only takes the 2D scan, but that can be that also can be developed. We can do the 3D scanning also. So then we have to use the two sensors. Difficult to display the detected object as a point source, but still we are working on that. We are developing that algorithm. the white colored objects are detected better than the other colors. That is another limitation that we had when we are using IR. Conclusion. Mainly, our idea was to design a type of close proximity infrared radar system. There are many improvements that we can make to our system in order to create better results. First of all, we need to increase the range of the detection, not to limit our input signals as much to get accurate results. We have designed and developed an IR radar system useful for the teaching purposes. However, there are few improvements that can do without much cost, like show the object as a point. We can increase the sampling rate of analog to digital conversion. By increasing the baud rate, we can improve the better response. Thank you very much.